Hi, I'm Josh Carlin, a software engineer working on Chrome in the Cambridge, Massachusetts office.
And I'm Mike Taylor, an engineering manager on the Chrome Privacy Sandbox team.
We're going to talk about Chrome's umbrella effort called the Privacy Sandbox, and it covers a lot of different projects that I'll try to give you an overview of. So let's start by talking about composability on the web. Websites could have third-party experts to do their analytics, their video serving, maps, comments, recommendations, or lots of other specialist functions for them. Third parties are great. Composability is one of the web's superpowers. And a huge role that third parties play today is their advertising. Most pages get their ads from third parties. When you visit a news site, it probably has ads that were placed there by one of 100 companies in the ad placing business. This provides sites with tens of billions of dollars a year from ads placed by third parties. But there is a problem with the system, namely privacy. A few years ago, at the Pet Symposium, actually in 2018, there was a paper titled Diffusion of User Tracking Data in the Online Advertising Ecosystem. And what they did is they augmented a browser to keep track of which sites were being talked to as they traversed the web. And in their analysis, they found that 52 companies had access to at least 91% of the average user's browsing history. And over 600 companies had access to at least 50%. These are kind of shocking numbers, even to us as web browser developers. And I expect they're shocking to website developers too. If you're building your own site, you still might not know all the third parties who could be pulled in when it runs. It's like knowing your whole supply chain. Transitive dependencies are hard. And even if you know everyone in your chain, you still might not know everything that they're doing. There's a lot of changes being made by browsers in response to this, and some have already eliminated third-party cookies. But this needs to be done carefully. The ability to personalize ads based on data collected about cross-site behavior turns out to be a huge component of what generates revenue on the web today. The ads folks at Google ran an experiment on the top 500 sites where Google places ads, and they treated ad requests as cookieless and measured a 52% drop in revenue paid to publishers. And looking specifically at news sites, the average revenue loss was 62%. The Google study is in line with other academic and industry analysis as well. And just to be clear here, I'm not talking about the ads on Google search. We're talking about the revenue of the other sites out there that Google hosts ads on as a third party. Helping the open web to thrive is a mission for Chrome and is vital to Google. So we want to prevent cross-site tracking, and we also want the web to thrive. So what is Chrome going to do? We announced in January that we're planning to get rid of third-party cookies with a 2-year time horizon. Other stuff will be happening to cookies between now and then. For example, we've changed the defaults so that even while third-party cookies are still allowed, they need to be explicitly labeled as such and can be sent over HTTPS only. But their time is coming to an end. There are lots of important things that third-party cookies are used for today, and we need new ways to support those use cases. So we're hard at work on developing a collection of new APIs, ones that are designed to meet those needs without making cross-site tracking possible. Before we take third-party cookies away, we'll give developers a well-lit path that will keep working even as we improve privacy. But as I said, a lot of money rides on using cookies for cross-site tracking. And that means there's a large incentive for various parties to move to other, more covert tracking techniques when cookies aren't available to them. When we get rid of third-party cookies, we want that to really stop cross-site tracking, rather than triggering a years-long game of whack-a-mole against widespread circumventions, which have been playing out with the other browsers. So the other reason the well-lit path is so important is that it gives developers an option that's better than an endless circumvention war. And when we say get rid of third-party cookies, that's a statement about technology, but it's really a shorthand for a more abstract goal. So what are we actually trying to prevent? Well, we published a privacy threat model where we state the goals of our project. It's really about partitioning your identity when you're on the web. Different sites might each have their own notion of your identity, but those identities should remain distinct from one another. Me while I'm visiting site A is distinct from the identity of me while I'm visiting site B. And the central privacy threat is joining these per-site identities across first parties. Third-party cookies are an example of what we should more generally refer to as unpartitioned state. Any web-exposed state, which is the same when the user is browsing two different sites. APIs like local storage, IndexedDB, or service workers cache storage are all examples of state which we're going to partition, so that you can't store something while the user is visiting one site and retrieve it while they're visiting another. There may be times when the user genuinely wants multiple sites to know the same identity, or wants a site to know some of their real-world identity. As an extreme example, obviously your credit card info is the same no matter what site you're on. That's fine as long as the user is giving out information or joining up identities deliberately. But we certainly don't want it to happen automatically, with no user intent, or while they're just trying to go about their regular browsing activity. Note that partitioning identity is not the end of privacy discussion. For example, disclosure of sensitive information about you can violate your privacy, even if it's just to a single site. There's work going on in the W3C's Privacy Interest Group to write a more comprehensive privacy threat model for the web. So now I'll give you a whirlwind tour of both the new APIs and the anti-circumvention work. There's a lot of individual projects under this umbrella, and many of these are extremely cool work backed up by innovative research. So my apologies, but this will really just be an impression of the range of work going on with just a sentence or two about each one. If you want more details on any effort, look for pointers on the Privacy Sandbox page at chromium.org. So what are these new APIs and what are their use cases? Well, let's start with the use case of combating spam or fraud or invalid traffic. We have an API proposal here called Trust Tokens. It's an amazing tool that lets the browser hand a message from one server to another in a way that is cryptographically secure, but can be provably constrained to something like a single bit of information, like, I trust this user. So you might be on site A, and while you're there, the site says, oh, I've seen you for a while, I know who you are, I'm going to send you a bunch of tokens that say that I trust you. And then when you're on site B, they can say, I don't know who this user is, but if I knew that site A trusted them, then that might be meaningful to me. So please give me a token from site A, and that token will tell them site A trusts them, but it doesn't say who the user is. Then there's measurement APIs. One specifically for ad conversion events, so that advertisers can learn which ad clicks that it paid for led to purchases that made it money, even though they can't actually tell which visitor on the publisher site matches which visitor on the advertiser site. And there's another API for more general aggregated measurement with infrastructure based on secure multi-party computation. And it makes it possible to learn statistics aggregated over a population, even while there is provably no way to learn anything about any specific user or event. So you might ask, how many users saw this event, or what was the average size of the event, without learning which users or their exact sizes. Then we have ad targeting APIs. Flock is the first one, and it provides interest-based advertising at the group level. It's an in-browser clustering of similar users into large cohorts that advertisers can learn about over time and choose to advertise to as a group rather than to individuals. Another API, TurtleDove, allows advertisers to create their own group to show an ad to, without the advertiser learning what sites any individual person visits, and without site owners learning ads being shown to any particular person on their site. Finally, there are many more than I have on this slide, but the last I'm going to talk about today is a federated login use case, and it's WebID. WebID has the browser intermediate the data exchange between the site you're visiting and your choice of your identity provider, and making sure that the information is only shared when you explicitly intend to do so you can understand what the information being shared is. So that's a glimpse of the well-lit path. But what are we going to do to make the workarounds harder? Well, for one, there's cache partitioning. I mentioned access to global unpartitioned state through APIs like cookies or IndexedDB, but the browser also has many caches which also present global state, and their contents may be subject to inspection directly or unintentionally via things like timing attacks. So we need to partition those. We also need to combat fingerprinting. Our main effort here starts with measuring how much browser instance identifying information is given out as websites use various browser APIs, with the intention of distinguishing normal from egregious information collection. For instance, you want to be able to tell the difference between a site that uses 3 fonts to display text in a nice, attractive way versus a site that tries to use 500 fonts just to create a hash of which subset are available for that user to identify them. We also need to address network level tracking. That covers things like DNS over HTTPS and encrypted SNI, which target attacks where an on-the-wire observer like your ISP could build a profile of your browsing. And then there's IP address privacy, where we're considering a basket of possible approaches that span technical and audit-based and policy-based, but all of which have challenges. And there's more, as people who want to track get increasingly desperate. So now I'm going to hand the rest of the talk over to Mike.
Thanks, Josh. That was a good overview of the mission of the Chrome Privacy Sandbox team and how we're planning on making that happen. For the next part of the talk, I'd like to spend some time explaining some of the concepts that Josh introduced in more concrete terms. And my goal for this section is to lay out a few key principles you can keep in mind to help the Privacy Sandbox initiative when you're developing new web platform APIs. And it's important to remember as we evolve the web platform by adding powerful and useful capabilities that we need to make sure we're not just introducing new tracking mechanisms. First, let's dig into some of the concepts and terminology that you should be aware of. And these should help you think about possible scenarios to anticipate and document in the security and privacy considerations section of your design documents, which typically is like the very first thing you think about and write down, or maybe not, depending on how that works. So let's jump back to this page we saw before. And remember that it's composed of sub-resources. And some are first party and some are from third party. So let's take a look at that. If you look at the top level URL, you can see this is chromeu.com. This is not a real URL, but last I checked, you can purchase it for like $280. But so that's an important piece of information to keep in mind. On the top right, we've got a login iframe served by the subdomain accounts.chromeu.com, chromeu.com. And so this belongs to the same registrable domain as the top level. Further below on the right, we've got an iframe from chromeu-blog.com, which is different than chromeu.com, but we can assume that they're related somehow. And we can see that the iframe contains links where a client identifier is being passed as a URL parameter. And this is typically used to measure and understand traffic and usage across related sites. Now let's look at the two red boxes. On the top level, we can see that the page source is a third-party script from an analytics service. And down on the bottom right, you can see there's an ad iframe served from a third-party domain, which has some pretty awesome red shoes. So now that we've identified first party and third party, like what does that actually mean? What constitutes a first party? Many web platform features today rely on the notion of a site. Typically origins with a common scheme and registrable domain are designated as being same site or first party. But in reality, in practice, we do see domains that are arguably first party by virtue of ownership by the same entity. So from the previous example we looked at, we saw that Chromeu and chromeublog.com, these should probably be treated as first party to each other. We're currently working on a proposal called first party sets that will enable this association and provide a more satisfying definition for first party. Requests are considered to be made in the first party context when the URL being requested is first party with the top level document, as well as with any ancestors in the the frame hierarchy. Conversely, we can define origins with a different URL scheme or registrable domain as being third party to each other. Going back to our example, the sub-resource requests to third-party-adtech.com and third-party-analytics.com are made in a third-party context. However, it's important to note that if you're including a third-party analytics script in the top-level document via script tags, versus an iframe, the script now has access to first-party storage and script-visible cookies owned by the top-level site, chromeu.com. So it's not always super clear what context you're in, and developers need to take care there. Here is a pretty simplified scenario of how cross-site tracking of users is enabled through this state. That's available only in third-party contexts and primarily through cookies. So this is something that illustrates how two different sites can be used to build a profile of a user as they surf the web. So let's assume chromeu.com embeds this third-party iframe, and that responds with a cookie that identifies the user. And then that same user heads over to New York Times, for example, in a different session. If New York Times happens to embed that same iframe, the browser will now send the previous user ID in the cookie along. And the third party also has access to information about the page you're visiting. And this is, we saw before, this can be passed along through URL parameters. So now the third party can compile your browsing history across all the sites that they're embedded on. However, this is, users, we can still clear cookies. You can have privacy extensions installed, or you can manually go into settings. So you have a little bit of control of forcing third parties to forget who you are. A much more problematic way of tracking users is known as browser fingerprinting. Essentially, a site can inspect or query information that can be used to extract a pretty unique fingerprint to identify you on the web. And this technique removes reliance on availability of third-party state and is unfortunately persistent for clearing of state and history. So they don't even need to know where you've been to come up with a unique identifier. You may have heard of certain libraries like Fingerprint.js or Fingerprint.js2. And these can be used and are used today on the web to track people. Fingerprinting, the way it works is essentially it relies on the HTTP headers and the APIs that are available and that it can query through JavaScript or through the network. And each of these reveals small amounts of identifying information about the device. It can be hardware characteristics or connected media, or they can identify something about the user through their preferences or settings. And when combined together, they can form a relatively identifying stable fingerprint. And sometimes we refer to this identifying information as entropy. And Wikipedia gives us a useful definition here as the average level of information present in a variable's possible outcomes. So our team, we estimate that around 34 bits of information are needed to uniquely identify a device. And that's not a whole lot if you think about it. And so when analyzing the potential for an API to reveal fingerprints, we typically think about how many bits of information it reveals and what the entropy distribution looks like. Our goal is to reduce the amount of information an API can give away while still accommodating the usefulness of the API. And there's a couple different kind of fingerprints you can think about. The first is stable fingerprints. These are, believe it or not, relatively stable within the order of a few days. And they're likely different for different people. And as I mentioned before, clearing browser state or history is not going to make this go away. A couple of examples of this are performing canvas operations and then reading back the pixels to fingerprint you based on your graphics stack. Or as was already mentioned, extracting font information. So I'm curious if, raise your hand if you have not installed a font in the last 24 hours, or you've not installed a GPU card. And then I guess, because this is a ridiculous thought experiment, raise your hand if you actually just raise your hand and you're alone in your bedroom watching this online. Got it. So that's how you can think of stable fingerprints. There's another kind that's ephemeral. And as the name suggests, it's not stable. This will largely depend on context and it will change over time, but you can use certain APIs, you can correlate and join them and by observing events or volatile attributes across site boundaries. So for example, device orientation, ambient light sensor events, accelerometer properties. Site A and site B can attempt to measure how sunny my office is, join those together and say, I think this is my tailor. Use curtains. So now that we've kind of learned some of the concepts, let's talk about design considerations to keep in mind to prevent the possibility that your feature becomes a novel means for cross-site tracking. And these are grounded in the privacy threat model that Josh introduced earlier. And I'd like to remind us of a key principle that Josh talked about as well. Your identity on the New York Times should not be correlatable with your identity on CNN.com, for example. This is not something we want to enable. We talked earlier about how such identity joining is possible today with state available in third-party contexts and how we're tackling those. However, there's even some less obvious mechanisms that have been used as cross-site communication channels. So people can use new web platform features in surprising ways. A couple of examples, if you go read up on HSTS supercookie, which is in theory a theoretical attack, but if a person embeds, let's say 6 or 8 or 10 iframes pointing to different subdomains, they can create enough information to identify you across visits, depending on what the HSTS returns. What its cache returns, rather. There's also Evercookie you may have heard of, which these were the zombie cookies famous a few years back, where they were effectively impossible to delete. And they leveraged a variety of browser storage mechanisms, including cookies, flash cookies, and other means. I should note this is not possible in Chrome anymore. So you definitely want to avoid like ending up on this slide in the future by introducing new tracking vectors. So if some practical advice, if you're adding a new type of state or cache, consider partitioning it by the top level site or even perhaps by the document in addition to that. And this ensures that the third party doesn't have access to shared state across many first parties. If you're designing a new API with the explicit goal of allowing cross-site exchange of information, such as the new APIs that Josh talked about earlier, you can apply statistical techniques such as fuzzing, the information with noise, and aggregation. You could also use low entropy identifiers, which divide clients into broad categories. For example, we're developing a new API called trust tokens to propagate a notion of trust for anti-fraud applications. We don't share the user identity across sites, but we do convey information about whether the user has any tokens and limited metadata encoded into the tokens. And lastly, per-site identifiers, APIs such as for federated login, which have the ability to hand out global identifiers, should provide per-site identifiers instead. And if you suspect your API reveals details about the device or profile, a few mitigation to consider include data minimization. You can focus on reducing the number of entry bits by rounding off or quantizing values, for example. One possible technique is to gate the access with informed user consent, which this will prevent drive-by fingerprinting, for example. But it should be noted that this is pretty tricky to do right. Consent fatigue is a real thing. We don't want to train our users to just like always click yes so you can get at your cool new feature. And the UI space around permissions, it's not entirely clear which sites have been granted the same access and if those can collude or synchronize in the background and build a profile out of that. And likewise, once you've given that permission doesn't prevent identity joining after the fact. Another thing you can do is restrict API access or events only to focus top-level sites. That is a top-level browsing context that's in the active document. You can also delegate via feature policy if you need to provide access to embedded frames, if you take that approach. And this fits well with the intended usage model for most APIs and can help mitigate fingerprintability with APIs such as device orientation events. That way some inactive tab or iframe, it really doesn't need to know that my laptop is upside down. You can also convert passive fingerprinting to active fingerprinting. One way to think about this is instead of wearing a name tag which makes your name implicitly visible to everyone, you may prefer that people ask you for it. And so this is our talk. The Chrome Privacy Sandbox team, we proactively review new intents that end up in Blink Dev. So we may be in touch if we have questions about some of your design documents or intents to prototype or ship. But you can also reach out to us proactively with questions and seek advice on our mailing list at antitracking@chromium.org. So thank you very much.